Okay friends, here we start our lessons. The flow of lecture for electrostatics would be in this order. The first we have electric charge, and this will be followed by properties of electric charge. Then we have Coulomb's law and applications, and this is followed by electric field and electric field lines. And again, this is followed by electric dipole, and next we have finding of electric field due to electric dipole, and this is followed by electric potential, and next we have capacitors and Van de Graaff generator. Objectives. After studying this lesson, you should be able to state the basic properties of electric charges. You should be able to explain the concepts of quantization and conservation of charge. And you also should be able to explain Coulomb's law of force between electric charges. And you also should be able to define electric field due to a charge at rest and draw the electric field lines. And you should also be able to define electric dipole moment, and electric field due to a dipole. And you also should be able to state Gauss theorem and derive expressions for the electric field due to a point charge, a long charge wire, a uniformly charged spherical cell, and a plane sheet of charge. And also, you should be able to describe how a Van de Graaff generator functions. Alright, the first topic goes to electric charge. Electric charge is the property of protons and electrons, which gives rise to electric force, electric field, electric potential, etc. So as per William Gilbert, he says that charge is something possessed by material objects that makes it possible for them to exert electrical forces and to respond to electrical forces. For example, say if this is the proton and this one is the electron, and this proton and the electron actually they are matter, and this matter they possess or they have a property, and because of that property they are able to attract each other or they are able to repel each other. Like between proton there will be repulsion, proton and electron there will be attraction. So this property possessed by this matter such as proton and electron, that property would be called as electric charge. And electric charge is a scalar quantity as it does not obey vector laws. All the laws of vector are not applicable to electric charge. This is the reason why electric charge is a scalar quantity. In nature, we have two types of charges, and in the lower classes you have also seen that like charges repel here. So these are the like charges, they repel. Similarly, you have negative charges, they also repel. And unlike charges such as a proton and an electron, they will attract. Okay, we'll see this property here. When a body loses some electrons, it becomes positively charged. We'll try to explain this. Let this be the matter, and the matter is electrically neutral. It is because the number of positive and the negative charges are exactly equal. That's why this is electrically neutral. Now let us assume that we also have another similar matter here. This is also another material body, and as I said before, this also should be electrically neutral here. Now we'll take a case. Let us assume that one electron from this matter, the first matter, is being transferred here. If this electron is being transferred here, if this electron has been removed, let's say it has been removed right now, and it is being transferred to the other side, this is the excess electron, and between these two charges, positive and negative, they cancel, and this body, initially it was neutral. This body has excess positive charge. That is why this body would be positively charged. On the other hand, if we look at this case, positive, negative, they cancel each other. This is called neutralization. And after they neutralize, this matter has excess electrons. That's why this body would be negatively charged. So now the conclusion is, when a matter is losing electron, the body becomes positively charged. This is due to loss of electron. On the other hand, when this body gains electron, the one who is gaining electron this would be negatively charged here. Each electron has its own mass. The mass of electron, this is equal to 9.1 times 10 negative 31 kilogram. So now, as you can see in the first case, when the body is losing electron, there should be a decrease or reduction in the mass here, because each electron has its own mass. So when electron is being removed, the mass of the electron should be decreasing here. So we can say that when a body is positively charged, the mass of body decreases. On the other hand, when this body is gaining electron, and as I said, each electron has its own mass, so if this body is gaining electron, there should be increase in mass. So the conclusion is, when a body is positively charged, the mass of body decreases, and when the body is negatively charged, the mass of the body increases. And here, the decrease in mass of a positively charged body, this is equal to number of electrons lost by the body multiplied with mass of electron. This one we will elaborate here. So we'll find the decrease in mass of the positively charged body. So let us write here decrease in mass. Now it should be equal to number of electrons lost by the body. Say in this example, we have seen that one electron is lost by the body. So this number of electrons should be 1, should be multiplied by the mass of an electron. And the mass of the electron is here. So you can write 9.1 times 10 negative 31 kilogram. So it becomes 9.1 times 10 negative 31 kilogram. So this is the decrease in mass when a body is positively charged by losing one electron. This is the way how we calculate the decrease in mass in the case of a positively charged body. Now we will move on to the next topic here. It says that when a body has excess electrons, that is gaining electrons, then the body becomes negatively charged. The explanation I have already made clear. When a body has excess electrons, such as this case, then the body becomes negatively charged here. Mass of negatively charged body is more than mass of neutral body. This is true because once the body is negatively charged, the body has gained electrons. That's why its mass should be increasing. Then, how to calculate the increase in mass of a negatively charged body? This is also the same here. In case if this is the neutral body and if it is gaining electron, this is the neutral body and this is gaining electron. How to find the increase in mass? Increase in mass must be equal to number of electrons gained by the body. In our case, we have one electron gained. This is multiplied with the mass of an electron. So this is 9.1 times 10 negative 31 kilogram. So it gives 9.1 times 10 negative 31 kilogram. So this is the increase in mass. So the conclusion is when a body gains one electron, its mass increases. This is the conclusion here. So gaining electron means negatively charged. Okay, now we'll see in this case. On a neutral body, number of positive charges is equal to number of negative charges. So net charge on it is 0. In the case of a neutral body, the number of positive charges is actually equal to number of negative charges. Due to neutralization, it means cancellation of the opposite charges, the body does not have any excess charge. This is why this body has no net charge. So the net charge should be equal to 0. In the next case we have, on rubbing, due to friction, one body may lose electron, and if it is losing electron, this should be positively charged, and the other body may gain electron, and it should become negatively charged. When you have a body here, this is being rubbed with another body. So this is A, this is B. There is no definite rule that the body A should be losing electron or it should be gaining electron. However, it is certain that one of the bodies should be losing electron and the other body should be gaining electron. And that electron simply cannot disappear, as this will violate the law of conservation of charges. Let us assume that on rubbing, the body A is losing electron. That's why it should be positively charged, and if this body is gaining electron, it should be negatively charged here. If the body A is losing electron, the electrons, these are the electrons which are loosely bounded to the nucleus. For example, this is the nucleus and these are the orbit of the electrons. And if this material has loosely bounded electrons, these are the electrons which are being transferred during rubbing. And this transfer of electrons or gain of electrons usually takes place in the case of insulators. You might have heard about a comb. When it is being rubbed on dry hair, it can attract small pieces of paper. This is because the comb itself, this is a perfect insulator, and paper is also insulator. On rubbing the hair with this comb, the comb, it becomes negatively charged here. It means if this is the hair, electrons would be transferred from hair to comb. That's why the comb will be negatively charged. And when this negatively charged comb is brought near the pieces of paper, they will be attracted due to electrostatic induction. There is a separate video on this. I will be showing that also. And the next point is, during landing or takeoff, the tires of an aircraft get electrified. This is happening during takeoff or landing. Therefore, special materials are used to manufacture the tire of an aircraft to avoid electrification. While landing or takeoff, the tires get electrically charged due to friction. And if more and more charges are accumulated on the tires, it may cause damage to the metallic body of the aircraft. In order to avoid this, the tires of the aircraft are made slightly conducting, so that all the accumulated charges may be discharged to the ground here. This is possible by adding carbon compounds. Carbon compounds are added to the rubber, which are used to make the tires of the aircraft.